Hello, everyone. It's a beautiful afternoon here in Florida, and I'm having a day like Groundhog Day, the movie, where everything I do, I need to do twice because I didn't do it quite right the first time. Anyway, I'm really hoping this video won't turn out that way, and it will be perfect the first time. Anyway, as I said last time, what I write about attempts to describe what self-transcendence is and how understanding that allows anyone to live an exceptional life. And so in these many videos, I've been hoping to demystify the worlds of physics and modern phenomena so that anyone can understand what they are, what's going on with these experiences, and how to use that information to better their life, to better your life. But quite frankly, it's going to take some familiarity with science to really appreciate what is going on with these experiences. And so here it goes, science class. Now, science is a subject many of us avoided in school. Yes, it is all over the media, but it's a subject that very few of us pay attention to. It's in the news, it's in popular books, things continue to be written about it, and the advances in science often make the headlines, but what is science really? It's a good question, at least I think it is. Well, to me, science is an attempt to measure and explain the world around us in terms that will lead to the most accurate predictions. That's what scientists want to do. They perform many experiments to try to disprove theories on how something works. So one branch of science is called physics. We've all heard of that, which deals with phenomena that govern our everyday lives, like gravity, electricity, and magnetism, things very important to our day. Now, just a little history. Galileo, I think we all know, discovered something called inertia, which is crucial for understanding gravity, the first point in physics. Inertia just means that if something is moving completely undisturbed, it will go on like that forever, coasting at a uniform speed in a straight line. The law of inertia is necessary in order to provide for gravity to be modeled, and it proves that there's a force needed to control the motion of the planet around the sun. Otherwise, the Earth would move in a straight line through space. Well, that would be terrible. The orbit of the Earth, therefore, isn't due to the force around the sun, but rather to a force toward the sun. And so that force was then discovered to be gravity. Gravity is where every object in the universe attracts every other object with a force that's measurable. The various distances of the planets away from the sun allow for their orbital movement around the sun without being completely pulled into it. So in this same way, the Earth is spherical, really, because everything attracts everything else to it, like a giant ball hugging itself, and that's why the Earth is round. Newton, another key figure in physics you might remember, then went on to mathematically describe gravity by watching apples fall from trees and wondering why they always fell the same way, perpendicular to the ground. His was a physics problem. Newton tried to explain how fast things fall and what they do when they fall, but he didn't comment on the machinery of gravity, the machinery of it. So he proved that they did, but he didn't prove why they did. And while Newton was troubled by the idea of this action at a distance, he apparently made no guess about the machinery of it. Now, later on, Einstein, you remember him, Einstein's general theory of relativity is a theory which raises fundamental physics questions, and eventually an analogy was drawn to electromagnetism. However, no one since Einstein has given any explanation at all about how all of this works. It's simply accepted that physical laws, such as gravity, have an abstract character, and they work the way they work. Well, there is no definitive explanation for gravity that scientists have yet given. They have noticed that gravitation and other physical forces have many similarities. For example, the force of electricity uses a very similar mathematical equation and variables, as does Newton's law of gravity, and I noticed that myself. It was recently supposed that gravity might somehow change strength with the age of the universe. For example, gravity would somehow increase in proportion to the age of the universe. Many scientists no longer believe that's true. And so they believe that gravity is constant with the age of the universe. This means that it may not be affected by time. And we will get into time later. And in fact, we spoke about time in our prior videos. So other forces in what we call classical physics, and I call it classical because their study is an ancient one having to do with the motion of bodies, are electricity and closely related to it, magnetism. These deal with the reasons for why things are attracted to one another and how energy moves around the Earth and around the universe. If you were to ask a physicist what the universe is made of, they would probably answer energy. To me, the force of electricity between two charged objects looks just like the law of gravitation. Perhaps gravitation and electricity are much more closely related than we think. Many attempts have been made to unify them, which falls under the name of grand unified theory, a theory in physics. Now, science, in particular physics, seeks to unite the different branches of its study. So each branch hopes to come up with the laws that apply to its own field of study, and possibly across many other branches of science, or even all of them. Like Newton, physicists want to explain the world so they can predict what will happen next. Physicists get very excited, as they would, when a theory is developed and isn't disproven after many experiments or observations. It then gets called a universal law. Now, Newton's theory of gravity is one such universal law. It's a simple law that applies to, explain, and predicts things that happen on Earth and beyond Earth. It's since been expanded on by Einstein's theory of relativity, which we'll get into later. But for many purposes, Newton's theory is a great approximation to Einstein's more accurate results. Phenomena like black holes, dark matter, and the like are all related to the idea that gravity is a universal law, so we can better understand the world around us. Now, all of these laws are based on what we will call materialism. Materialism is the belief that physical matter and its equivalent energy is all there is. Materialism is everywhere in modern science and remains almost entirely unquestioned by most scientists. The reason is that physics based on materialism is such a convenient approximation of our daily reality. Physics based on materialism has such remarkable accuracy that it's good enough for most practical purposes. And since the findings of Newton's and other in classical physics explain so many of the world's happenings so well, it's reasonable for someone to believe that those findings are all that's needed to understand everything in the world, from the tiniest particle to the most enormous galaxy. With that said, the miraculous occurrences in the now that we've talked about seem to defy these findings, and my own experiences do as well. Like the occurrences that I talked about in prior videos, they are often labeled as ridiculous, delirious, or just plain made up. But what most scientists don't say is that recent discoveries are increasingly disproving materialism. Beginning with Einstein and others, a new branch of physics called quantum mechanics, or quantum physics, you've heard of that, has thrown a big monkey wrench into what we think we know about how the world works. While traditional classical physics describes our world very well most of the time, it doesn't work at the level of the tiniest of the tiny, the smallest particles that make up the larger objects in our daily lives, like energy and matter. And a new branch of physics called quantum physics sprang up to form what we call quantum science. So what happened is that when scientists tried to apply the classical laws, remember those, to explain how the smallest possible bits of matter and energy behaved, they simply couldn't explain it. Specifically, when they tried to measure these tiny particles, a problem occurred which is now called the measurement problem. That measurement problem is at the core of the heated debate going on in quantum physics today. The reason is that the measurement problem is such an issue is that scientific experiments conducted over the last 50 years or so have come to suggest a highly controversial view. And this view suggests that the simple act of a being, a human being, looking at something, in physics this is called observing, we humans actually change what we are looking at. And the way we do that is through our thoughts. That would cause the definition of quantum physics to include the ability to change the behavior of atoms through thought. Well, you can imagine, at first this seemed so crazy that scientists couldn't believe it to be true, so experiments and theories were developed over many decades to try to disprove this conclusion. But none were able to do so. And to give you some background on why this is the case, we need to take a little journey into the wild, wild world of modern science called quantum physics. And that we will do in our next video. And so until then, here's to being in the now.